Another review item from Siglent. This has been given to me, well, loaned to me by Rob of Tapping Technologies. He's an agent. So I'll take a look and see what's actually in this thing. I already know, obviously, but you don't. Can you guess? Guess it down below in the comments. So this isn't just an unboxing video. I'm going to do some testing on it. I'm criticised for unboxing videos, which aren't unboxing videos because they don't watch more than 2 minutes. It's getting smaller and smaller. So here we are. Got a couple of big terminals on the back here. So it's a Siglent SPS5000X series power supply. This particular one is the 5042X. So it's 40 volt, 60 amps, 720 watts. A switch mode power supply. It's not linear, switch mode. Got a USB port there, got analog control protection cover, and it's actually got a port behind it. And it's got some labels here telling you what all the connections are. Yeah, that's what all the connections are on this thing. So it's got all sorts of stuff going on here. Interesting. It's got two 60mm fans, I suppose. LAN connection as well down the bottom. Surprised the LAN's not next to the USB actually. Just surprised it's not like the USB down here as well. Anyway, and also a multi-voltage AC input here, AC connector. And close look at the front panel. So small selection of buttons here, rotary encoder, clickable, another USB port. We have an OLED display here, which we'll see when we power it up. We do have a hard power switch, but it isn't running the power through it. This is, although it's a hard power switch, it isn't actually a hard powered device. It's a soft powered device, effectively, with a hard power switch. Yeah, we'll see on me. And this is a sticker from Rob. If you're in New Zealand, go and check that address out. Let's power this thing up and have a look at it. I've got power ready to go. Hard, soft power switch, I don't know what you call it. It's not actually a hard power switch. We'll see. Turn the power on here. Put in 220 volts. Let's go up slightly more. Let's go 230. Right. It's powered up. Fans kicked in. Here you go, boot it up. So I've got an OLED screen here which you can see flickering on camera probably. You might be able to see it flickering. 2.4-inch OLED. Not sure fan of the display. I think I would have preferred an LCD. Yeah, I don't know. I'm not a fan of that display, I have to say. So constant voltage currently set at 0 volts. No wattage. No amps. So that's showing 2 milliamps sitting there. 3 milliamps sitting there. Set to 14.6 at 14 amps output. That's what it's currently set to. So I've got a menu, so look in there first. Okay, so we've got system, version, 36 times startup. Oh, well, someone has been busy with this thing. Rob's been playing with this one quite a lot. So this one actually shows 40 volts, 60 amp, 720 watt on there. And there's some information about the actual software versions and what have you there. Escape, I'm guessing, yeah. Default setting key sounds, it's got beep on it, which doesn't bother me, it's actually not that bad. I don't actually mind key beeps that much. I know some people are really annoyed by key beeps, it doesn't really bother me. Also, if you notice my voice doesn't sound quite right, I've been sick for the past week, so some kind of bug. Anyway, upgrade options, so this is no UDISC, okay, so that's obviously for doing firmware updates. MS mode settings. Oh, master slave, right, okay. Means you can actually link power supplies together. Yeah, I'm just going to leave it on that. Ball test, don't worry about that now. Okay, that's all that stuff. Configuration. Protection is on. Overcurrent protection. 66 amps. How do I go to the next thing. Can I change that? Change that one. Oh, there we go. Yes, that is it. There we go. Oh, that doesn't matter. What's it got to? 66 is the max, is it? Because 60 amps power supply. Okay, I'll leave it alone. It's fine. Shunt on and off. I don't know what the story is with that. Operating mode. Constant voltage, constant current. Yeah, okay. Priority mode. High speed or slew rate. Okay. And slew value. So you can change how quickly it will shove the current out. Not voltage, anyway. So if you need to be more gentle with the output, you can slow it down. That's nice. You can be more buffered. Output delay. On and off delays. Okay. Nothing set, so it's immediate. Output resistance. 0 ohms. Measure averages. High. Okay. So it's just for smoothing of the actual values. Voltage control. Local control. External voltage. External resistance. Maybe. Maybe it's a shunt. External shunt. Maybe. I don't know. Current control. Same thing. External voltage. External resistance. External on and off. Currently off. That's it. Okay. Communication. USB, GPIB, LAN. Internal temperature. GPIB 01. Okay. USB information there. And LAN. Oh, push the right button. And LAN currently off. Well, DHCP is currently off. And manual configuration. Okay. That's all standard stuff. What does that do? Nothing. Okay. Well, it seems to have a menu system. List. What can we do with this? I don't know. Push select to set up. Number of loops 1. Number of steps 5. Current step 1. Voltage set. Current set. Okay. There we go. Alright, so you can do like a stepped power supply output. So if you're doing testing on something, you can switch to power supply. Okay, I'll turn that back off, I suppose. Exit. Locking, recalling. Okay, set values. So I want to change these values. I can do that. Going sideways, and that one, and this will go somewhere else, or not. Set again. Ah, there we go. Right, there's current. Okay. That's fine. And to get back out of set mode, you can't just keep like pushing it. You actually have to push this one, it seems. Yeah, okay. And if you push this one, it goes into the last one it was on. That's what it seems to do anyway. Over there. There. Okay. Yeah, it does. It goes to the last thing it was actually on. That's nice. So I suppose really the only thing to do now is to actually load this thing up and give it a test out and see how it handles it. So before I reconfigure everything, I'm going to show you something. Got to turn the hard power switch off. Yeah, it's not a hard power switch. There we go. Now it's off. Right, I've got some stuff hooked up now. Got my Siglent electronic load hooked up. And that can do up to 30 amps. So let's just turn the output on. Output should now be on. We are. I've got it set to 10 volts, 10 amps. It's only generating 100 watts. I've got a fairly thick cable here. It's about 8 gauge. So that should be reasonable. Shouldn't get too much voltage drop. Electronic load is seeing 10.0006 volts. I'll change views soon and we can see what we're actually getting. But you can see there's a bit of discrepancy between this and what's on the load. Let's turn the load on. It's currently set to 100 milliamps. Yep, and that's looking like it's basically right. Yeah, a bit closer. So 1 amp. This is nothing but this power supply. I'm just checking accuracy of the displays and what have you right now. I am getting a voltage drop to the electronic load. So my electron load will see a voltage drop, but the voltage drop won't actually be there. If I showed a separate power supply measurement, I'd actually show what the output will be, and it won't actually be dropping as much as you'll see. So let's go 5 amps. So 5 amps. Yep, no worries at all. It's looking very close there. 10 amps. So that should be basically maxing out now, and you can see that it's doing exactly 10 amps and the voltage is collapsing because I've reached the current limit. So that's exactly what it's supposed to do. So it's going to set, increase the current limit. There you go, it's no longer limiting. Let's wind this up to say 20, let's go 30 amps. Let's go all the way to 30. Let's do it. So let's do 15 amps. Yep, okay. Starting to see a bit of a discrepancy on the display there now. 20 amps. Fans kicking in somewhere, I'm not sure whether it's on the load or this. 25 amps. There you go, 25 amps. And we're seeing about that there too. That's working fine. Accuracy is not too bad. Fans in this is what's ramped up, not the load. Interesting. So I'm going to change the view to multimeter, which is measuring directly on the output terminals of the power supply and the load. Reason being, this load, it does tend to get a lot of voltage sag when not using external sensing. The external sensing connectors on this thing are on the back. I just rather just hook up the multimeter and just use that. It's just easier. So let's actually do this test again. Let's do back to 1 amp, which will turn the load on. Alright, so see 1 amp doing fine. Sag is basically nothing there. 5 amps. Again, very little sag. 10 amps. 15 amps. There's 15 amps. Again, very little sag. 20 amps. Still doing fine. Look at the voltage, there's nothing there. Nothing wrong with that. 25 amps. Still fine. And 30 amps. That's going to start collapsing the voltage down because it's right at the limit of what it can do. Well, what the limit of what I've got it set to. So let's do 29 amps. And that should be fine. There we go. Voltage is no longer collapsing. Okay, so I think I've got a 30 amp current limit set on this, so don't accidentally stress my electronic load too much. I mean, this is technically a 1020XE, which is the 200 watt load, not the 300 watt load, but I've kind of improved it slightly. And anyway, I think physically the same, it's just a software thing, I believe. Anyway, but I've seen no reason to worry about that. As you saw, voltage sag minimal. Right, flow from no current draw to 29 amps. Really volts. And as you saw, I did actually see a peak up in voltage there as it shuts off. So yeah, it just comes up very slightly. So it could be an inductive thing because I've got all these long cables. These wires are quite long, so it could be a bit of an inductive pickup there. As you would get, it's a bit like a switch mode power supply, as in like a buck converter or boost converter, how they're switching on and off to create more voltage. It'll probably be the same thing. We get a load shuts off, you probably get a spike. That's not too surprising. So I'll just change my multimeter settings here to make it a little bit faster. Actually, let's make it even faster again. And this will help show any spikes. So let's load up a little bit, get it working hard, then shut it off. Nah, didn't show anything at all. Okay. Just change the display, histogram, so it shows up when it's actually working. And again we'll unload it. Did have a slight high voltage spike there. Nothing really showing up there. Trend chart, I don't think that'll show that much either, to be honest. They'll probably change this scaling. There we go. So on load. And then offload. Auto scale on that. Yeah. So it's looking like it's handling it okay according to multimeter anyway. Well, let's give you an even closer look. I've changed the scale across here now, so it should show a little bit more detail. Also changed the power line circles, things like that, just a bit lower. Just trying to get a faster response time. So let's do this again. Let's drop down, let's do an auto scale on that. Interesting big surge there. Okay. Auto scale there. Tapping off. Interesting, there's a little spike, look at that. Not by much though. Not a big spike, it's only small. So let's change that again. And you can see the extremities here. I'll just change it to like a 20-second time, give me time to surge it on and off. So that's the on drop, and that's the off spike. So it's not a big spike. You actually see what the extremes are here. So minimum is 996, so 4 millivolts down, and the maximum is 18 millivolts up. So that's not exactly disastrous, is it? That's pretty good considering it's 30, well, basically 30 amps I'm drawing through it and causing that big surge. So that's alright. So you can also see that trend I'm seeing there, look how many samples it's taking. Hundreds of samples each time. Each step is hundreds of samples. So I can definitely see these spikes and stuff in there. Not a problem. So obviously this thing is controllable via the network. So as you saw, it's got network settings in there for USB and for Ethernet. So you can actually control this from any other software. There's a command set which is available in the manual, and you can control this device, remotely set it, remotely read the values, and remotely control it and that sort of stuff. So that's exactly what some situations require to do testing. For example, you want to be controlling this power supply and monitoring something else. One thing I haven't looked at yet is the actual overall voltage accuracy, so I can actually do that. As soon as I've got the multimeter hooked up, I might just look at the actual accuracy of the outputs and see how accurate the voltage setting actually is. So I'll try a few different voltages. So it's just let's do 1 volt. Why not? And you're getting 999 millivolts basically. It's actually dropping down, obviously it's discharging capacitors. It's about 998.7 millivolts. 2 volts. I'm not going to do all the voltages because that is ridiculous. Just to give you an idea of scaling. That's 1.9985 volts. So 10 volts we already saw. It's going to cover that. Actually I'll do 5 volts. That's a common voltage. Look at that one. 5 volts is 4.9987. 10, I'll just remind you what that is. That is coming up as 9.9994. 15 volts, another common voltage, is basically exactly 15. That's actually pretty good. 15.0003. So as per the meter. 20 volts. That's 20.0008. Very good. 25 volts. It's 24.997. 30 volts. 29.997. 35 is 34.997. See a trend there. And 40 volts is 39.997. And that's the limit, as it tells you. Okay, so it seems we're doing 997 for a lot of these voltages, even there. Just, yeah. So it's got up to 25.4 volts here because of the going to the maximum, which is obviously 40.4, and 3 volts is 2.998. So maybe it is very slightly out on some ranges. Maybe it's not particularly linear. A couple of millivolts here and there probably isn't really an issue, is it? I mean, it's within the scaling. It's probably well within spec. Don't forget to check out the other videos at the end here, other reviews I've done. Thanks Rob for lending this to me. I'll get this back to you shortly, and I'll catch you later. Bye. Silence.